Bismillahirrahmanirrahim. Assalamu alaikum. This lecture is for BBA 2. The subject is Business Mathematics. This is our lecture number 9, which is delivered by Ms. Zahra Arif. In this lecture, we will discuss about the sequences and series. Introduction. The inventor of the chess asked the king of the kingdom that he may be rewarded in lieu of his invention with 1 grain of wheat for the first square of board, 2 grains for the second, 4 grains for the third, 8 grains for the fourth, and so on for the 64 squares. Fortunately, this apparently modest request was examined before it was granted. By the 20th square, the reward would have amounted to more than 1,000,000 grains of wheat. By the 64th square, the number called for the world have been astronomically, and the bulk would have for exceeded all the grains in the kingdom. The basis of this story, a sequence of numbers that have a mathematical relationship, has a great many important applications. Many of them are beyond the scope of this book, but we shall explore the means of dealing with the numbers of practical and often entertaining problems of this type. Sequence. A set of numbers arranged in order by some fixed rule is called a sequence. For example, 2, 4, 6, 8, 10, 12, 14, and so on. You may clearly see that this is an infinite sequence, and there is a sequence that 2 is added in each number. Then the next one is 1, 3, 5, 7, 9. Again, 2 is adding in each number. 1 over 2, 1 over 4, 1 over 8, 1 over 16. Or we can see that the denominator is the square of the is multiplying by 2 with the previous one. Like 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16. In a sequence, A1, A2, A3 up to AN. A1 is the first term, A2 is the second term, A3 is the third term, and so on. Up to AN would be the nth term. AN would be the nth term. There are two types of sequences, a finite sequence and an infinite sequence. A sequence is called finite sequence if it has finite terms. For example, 2, 4, 6, 8, 10, 12, 14, and 16. By the end of 16, it has a full stop. It is not going on and on. There is no dot. So it is a finite sequence. An infinite sequence if it has infinite terms. For example, 2, 4, 6, 8, 10, 12, 14 up to so on. So it is going on. So it is an infinite sequence. Progression. If a sequence of number is such that each term can be obtained from the preceding one by the operation of some law, the sequence is called progression. Note, each progression is a sequence, but each sequence may or may not be a progression. This is for MCQs. Arithmetic sequence. A sequence in which each term after the first term is obtained from the preceding term by adding a fixed number is called an arithmetic sequence or an arithmetic progression, and it is denoted by AP. We can look in this example: 2 plus 2, 4, 4 plus 2, 6, 6 plus 2, 8, 8 plus 2, 10, 10 plus 2, 12. In the second example, 1 plus 2, 3, 3 plus 2, 5, 5 plus 2, 7, 7 plus 2, 9, and 9 plus 2, 11. Common difference. The fixed number in the above definition is called as common difference. It is denoted by D. It is obtained by subtracting the preceding term from the next term. For example, nth term, we will obtain D by subtracting AN minus 1 from AN. For example, in this 4 minus 2 is 2, 6 minus 4 is 2, 8 minus 6 is 2. Okay. Then 10 minus 8 is also 2. A general form of an arithmetic progression is, let A be the first term and D be the common difference, then general form of an arithmetic progression is A plus D, A plus 2D, up to so on a plus n minus 1 into d. Look, in the first term there is no d, in the second term it is 1d, in the third term it is 2d's, up to so on. In nth term what will we do? Third term there are 2d's, means 1 less d. So in nth term what will happen? In nth term d would be n minus 1. D would be n minus 1. Nth term of the journal term or the last term of an arithmetic progression. If a be the first term and d be the common difference, then a1 is first term, that is a1 plus 1 minus 1 d. a2 is the second term, a1 plus d is equals to 2 minus 1 into d. a3 is equals to third term, then a1 plus 2d, and what we call 2d as 3 minus 1 because third term. a4 is the fourth term, a plus 3d is equal to a1 plus 4 minus 1 into d. So we can generate the nth term with the help of it. Look, what we will do, we will write n in replacement of 1, 2, 3 and 4. So an is equal to nth term is equal to a1 plus, if it was 4 then 4 minus 1, if it was 3 then it was 3 minus 1, if it was 2 then it was 2 minus 1. Now it is n, then it would be n minus 1 into d. So nth term would be a1 plus n minus 1 into d, in which a is the first term, d is the common difference, and n is the number of terms. For example, find the seventh term of the arithmetic progression in which first term is 7 and the common difference is minus 3. As we know the nth term, what we will do? We will put the values in the nth term and we will get the answer. Here nth term is equal to an is equal to a1 plus n minus 1 into d. So a7 is equal to 7 because a1 is 7 plus n is also 7. So 7 minus 1 into d is minus 3. By solving it, we get the answer that seventh term is minus 11. Second, find the ninth term of an arithmetic progression. Here, minus 5 by 4, minus 1 by 4, 3 by 4, up to so on. So, they are asking about ninth term. It means n is 9, a1 is minus 5 by 4, and how we can get the d? We will subtract first term from the second term. So minus 1 by 4 minus 5 by 4. By simplifying it, what we get, the d is equal to 1. Now putting the values in the nth term of the formula, what we get, that a9 is equal to, as a1 is minus 5 by 4 plus n minus 1, that is 9 minus 1 into d is 1. By simplifying it, we get that a9 is equal to 27 over 4. Arithmetic means, if a, capital A, B are three consecutive terms in the arithmetic progression, then a is the arithmetic means of a and b. It says that the middle term, if there are just three terms, then the middle term would be the arithmetic progression. Arithmetic mean. So what we will do, if a, b are in the arithmetic progression, then a, we are going to prove that what is the formula, that a minus a is equal to b minus a. A plus a is equal to a plus b. 2a is equal to a plus b. So a is equal to a plus b over 2. The arithmetic mean of two numbers is equals to 1/2 the sum of the two numbers. For example, find the arithmetic mean. So of under root 5 minus 4 and under root 5 plus 4. But as the first one is a and the second one is b, by putting the values in the formula, that a is equals to a plus b over 2, we will get the answer, that is under root 5. Now that was just a single arithmetic mean. Now if we are asked to find the n arithmetic means between a and b, what we are asked about n, more than one arithmetic mean between a and b. The number capital A1, capital A2, capital A3, up to so on, AN are said to be n arithmetic means between A and B. If A, small a, capital A, A2, A3 up to so on AN, then D are an arithmetic progression. We may obtain the arithmetic means between two numbers by using AN is equal to A1 plus N minus 1 into D to find the value of D, and the means can then be computed. So we will see it with the help of an example. For example, insert three arithmetic means between minus 18 and 4. Three arithmetic means it is saying that find A1, A2 and A3. So now by putting three arithmetic means, we can clearly see that in an arithmetic progression now there are 5 terms. How many terms? 5 terms. In first term is minus 18 and the fifth term is 4. First term is minus 18 and fifth term is 4 and n is 5. First of all, what we will do, we need to find what is the value of D. So by putting these values in the nth term of the formula, an is equal to a1 plus n minus 1 into D, we will find the value of D. So as capital A1 is the second term, we know that A plus D is the second term. So minus 18 plus 11 over 2, what we get, the second term is minus 25 over 2. Then we need to find third term. If we will add D in the previous term, means if we will add D in the second term, that is minus 25 over 2 plus 11 over 2, we will get the value of A2. And similarly, when we will add the value of D in the third term in the A2, then we will get the value of A3, that would be minus 3 by 2. Series. The sum of the terms of a sequence is called in series. For example, 1, 4, 9, 16 is a sequence. But if we will write it as 1 plus 4 plus 9 plus 16, then it would represent as a series. Now, we will discuss about the arithmetic series. The sum of the term of arithmetic sequence is called arithmetic series. For example, 7, 11, 27, 37, 47 is an arithmetic progression. When we will write as in an arithmetic series, that would come 7 plus 17 plus 27 plus 37 and plus 47 up to so on. So first of all, we will see about that what is the formula of sum of nth term of arithmetic sequence. That is, the journal is, we will denote the sum by Sn. It is n over 2 a1 plus L is over here an, that is the nth term. So nth term is 1 plus n minus 1 into D. Putting the values, Sn is equal to n over 2 a1 and an is equal to a1 plus n minus 1 into D. So n over 2 is equal to 2a1 plus n minus 1 into D. So we can use these two formulas. The first one, that is Sn is equal to n over 2 a1 plus L. L means an. And the second one is Sn is equal to n over 2 2a1 plus n minus 1 into D. For example, find the sum of the series, that is 3 plus 11 plus 19 plus up to so on to 16 terms. So here what we have come to know that a1 is 3, D is 11 minus 3 is 8 and n is 16. Simply by putting the values in the formula of Sn, we will get the answer that S16 is equal to 1008, that is 1008. Second, find the sum of all natural numbers from 1 to 500 which are divisible by 3. So first of all, we need to know that which are the numbers that are divisible by 3. So 3, 6, 9, 12 up to so on, it will go to 498. After 498, beyond 500, there is no other number. So here we have come to know about A1 and AN as well. So we can use the first formula as well. That is n over 2. But here, still we do not know about that what is n. First of all, we will find n. For using n, what we will do, an is equal to a1 plus n minus 1 into D. We know D, that is 3, an is 498 and a1 is 3. By simplifying it, we get that n is equal to 166. Now we have n. We have A and we have D. By putting the values in the formula, we will get the answer that S166 is equals to 41583. If the sum of n terms of an arithmetic progression is 2n plus 3n square, find the nth term. So it is asking about the nth term which if we have the sum. What we will do, that they have given that Sn is equals to 2n plus 3n square. So we can form the series. How? If it is nth term, then we can find the previous term by putting n minus 1 in replacement of n. So 2n minus 1 plus 3n minus 1 square. So by simplifying it, what we get, that 3n square minus 4n plus 1. So an is equal to Sn minus Sn minus 1. So how we can find it? By subtract. If we know the sum of the nth term, we can find the value of nth term by subtracting the sum of n terms and sum of n minus 1 term. So an is equal to Sn minus Sn minus 1. Okay, sum of Sn minus sum of Sn minus 1. So an is equal to 6n minus 1. This was all about arithmetic progression. In our next lecture, we will discuss about the geometric progression. Thank you.